recorded.
So, good afternoon to all. In the last lecture, we discussed theory portion related to synthesis of mechanism, in which we discussed tasks of synthesis, steps in synthesis. At the same time, we also talk about one step in synthesis, that is nothing but a dimensional synthesis. And at the end of the lecture, we discussed there are different methods of dimensional synthesis, like a graphical as well as analytical method. As I told you, graphical methods we are going to discuss in practical sessions. So we are going to start analytical methods, which is portion or which is syllabus of a theory lectures, which will be asked for a theory examination. So we start with derivation, which will be important for solving different numericals. And that derivation is nothing but the topic is analytical method for dimensional synthesis of four-hour chain mechanism. And it is derived by freudenteins. Hence, sometimes it is also called as a freudenteins equation. So, for discussion of this freudenteins equation, or in order to derive this freudenteins equation, first we consider a four-bar mechanism. So, I consider this four-bar mechanism having four links of different lengths. So, let's say the fixed link is L1. This one is second link. We call it as L2. Length of the link is L2. This one is L3 and L4. So L1, L2, L3, L4 are the link lengths. And we know, let's consider theta is the angle made by this link L2 with fixed link, while phi is the angle made by link L4 with fixed link. So theta and phi, we can say angle made by input and output links at any instant. And this link L1 is a fixed link. Now we consider a Cartesian coordinate system. Let's say this one is x-axis and this one is y-axis. Now in order to get derivation of this freudenteins equation, what we consider four link lengths, let's say L1, L2, L3, L4, and two angles theta and phi, that is input and output angle. Now, considering these links as vectors and writing vector displacement equations or vector displacement relationships along x and y axis, we can write it as, means we have to consider vector equations for these links. So writing this vector displacement relationships along x and y axis, we can write it as, let's say along x axis we have to write so how can I write this vector relationship as this link length is L1. Let's say consider this L1 as vector L1. This one is L2 in a sequence. This one is L3 and it is L4. I consider this link length as vectors. These angles are theta. So how I can write this vector relationship? Or how I can write displacement equation in terms of vectors along x and y axis? Yes, as we know here, I can write it as along x axis. This one is L1. It is towards this side, left side. The vector is towards left side. This L2 is having some angle theta. So if I resolve this L2 in two directions along x and y, its coordinates are L2 cos theta and L2 sin theta. So I can write along x axis, I can write it is this one L2 cos theta, which is positive, plus L3 cos. Now see, this one is theta angle. So what we can write as, let's say this angle is beta. So L2 cos theta plus L3 cos beta minus L4 cos phi. What about L1 we can write? Yes, we have to write displacement relationships.
minus L1.
Yes, it is minus L1. Depends upon direction. So it is minus L1 is equal to 0. So it is your equation number 1, let's say. So I written vector displacement relationship along x-axis. Now how I can write along y-axis? Yes. Tell me please y-axis. I request all of you please write along with me. It's very simple equation we have to use. You have to derive. Yes, what you can write about y-axis? Let's start with fixed link. What is component of this fixed link? It is 0. As it is only along x-axis, parallel to x-axis. So the component of L2. Actually, I just write these components also here. So this one is L2 cos theta. This one is L2 sin theta. Just for explanation, I can write here it as L3 cos beta, L3 sin beta. And here we need to resolve like this. So its component is like this. So this will be L4 cos pi and L4 sin pi. But direction is like this. So tell me about y-axis, please. Yes. What we can write about y-axis? I request everyone please
L2 sin
be interactive. Yes, it will be
L2 sin theta.
yes L2. So this one L2 sin theta. I write y-axis L2 sin theta plus L3 it is upward. So L3 sin beta. Y component is upward.
Minus
And this is
L4
downward.
sin.
So it is minus L4 sin of phi. What about L1? Its component is 0. So it is equal to 0. And hence I can write it as equation number 2. So we return this displacement relationship along x and y axis. After this, I can write this equation as, I can rewrite this equation in order to get some terms from this. Let's say simplify this by taking this L3 term to one side. So let's say rewriting equations. One and two, we can write it as, let's say L3 cos beta, I'll take to one side. Hence it is L3 cos beta is equal to, so what you can write it as, it is L1 plus L4 cos phi and this minus L2 cos theta. This I rewrite the equation number 1. So let's call it as equation number 3. Please tell me if it is not visible or any doubt in between. Okay. Similarly, I can write in terms of L3 sin beta just for simplification. So L3 sin beta is equal to this to that side. It is L4 sin phi. Yes, minus L2 sin theta. It's equation number 4. Now, as I want to find out link lengths like L1, L2, L3, L4, I want this equation in terms of that. So I'll try to simplify these trigonometric terms. So in order to get L3, what I do is we can square and add these two equations. So by squaring and adding, equation 3 and 4. So by squaring this, so it will be L3 cos square beta. So see equation number 3, square and add. So L3 cos square beta, actually it is L3 square cos square beta plus addition L3 square sin square beta, left hand side. And right hand side, square of these 3 terms plus square of these 2 terms. So it will be, I'm writing here on left hand side, L3 square cos square beta, this term square, plus this term L3 square sin square beta. So I added and square LHS. What about RHS? We have to square that terms. So I have to square and add. So square this term and square this term. So I can write it as this single term L1 plus L4 cos phi minus L2 cos theta bracket square. Squaring and adding plus what is this one? L4 sin phi minus L2 sin theta bracket square. So all of you just simplify this. How you can simplify this term? Anyone can tell me simplification further?
So left hand side is L3 square because cos
Yeah, it's
square
very
beta
simple
plus
because
sin.
yes, it's L3 square common here. So we can take L3 square common into cos square beta plus sin square beta. And as we know, cos square beta plus sin square beta is equal to 1. So I'm writing directly here. It is L3 square is equal to, on right hand side, what I can write? How we can simplify, please? It is basically A plus B plus C square. You know the formula, trigonometric formula for square of three terms, A plus B plus C, let's say, by consideration of sign. Anyone can tell me? Yes. It is A square plus B square plus C square. Of course, we have to consider sign plus twice AB plus twice BC plus twice AC. So what I write here, by using that formula, I can write it is L1 square. Yes, please help me for this. L1 square plus, yes, please. L4, A square plus B square, L4 square cos square phi. Next term, minus, is it minus or plus?
Plus.
Yes, it is plus because I'm squaring it. So it will be L2 square cos square theta. So it is A square plus B square plus C square. Next, AB. So twice AB. So twice A is L1 and B is L4 cos phi. So twice AB. Next, twice BC, or you can say twice AC also you can write. So minus twice L1, we take this L1, L2 cos theta. And next one is this one. So I take first AB, then AC, and now BC. So minus twice, yes, it will be L2, L4 cos theta cos phi. It is simplification of first term. Similarly, we can simplify second term. So what it is? Yes, it is second term simplification. It is just A minus B square. A minus B bracket square. So A square plus B square minus twice AB. So I can write here it as L4 square sin square phi, that is A square, plus B square twice L2 square sin square theta. As it is A minus B square, it is twice minus AB. So it is minus twice L2 L4 sin theta sin phi. Okay, so this is simplification of the previous term. Now just try to get some common terms. How you can simplify it? Try to simplify more. So based on this, I can write now. If it is visible to you, just tell me whether next one is visible. What I'm writing here in continuation of this. Therefore, So L3 square is equal to, yes, try to take common terms. What I can write? Anyone please tell me simplification?
So we can take L4 cos phi square and L4 sin phi square together, and we can write it as L4 square.
Very
Uh,
good.
and then L2 cos theta square and L2 sin theta square together, we can write it as L2 square. And then we have L1 square, and then the rest.
Okay, now see. Yes, right, Ashbin. You can see here, I can take terms of L1 square, L2 square, L3 square, L4 square. As far as possible, I will take their common. So it is only one term of L1 square, that is here. No other term. So I write it as it is. So L3 square is equal to L1 square. Next, what about L2 square? Terms of L2 square. Check it. Take common terms of L2 square. So this one is L2 square cos square theta and L2 square sin square theta. We know what we can take common. Next. Okay. Can I write directly here what it is? It is nothing but L2 square in bracket cos square theta plus sin square theta. Further it will be, yes, that term is 1. I'm not writing again here cos square theta plus sin square theta. I'm directly writing here. What about L3 square? There is no term of L3. What about L4 square now? So it is, yes, similarly, here it is L4 square cos square phi plus L4 square sin square phi. If I take L4 square common, it will be cos square phi plus sin square phi. Hence I write here it as L4 square. So I get here L1 square plus L2 square plus L4 square by taking common terms of square. Now next, remaining terms. How I can simplify them?
L2, L4, cos phi, cos theta, sir. Don't
Yes, only 3 terms are remaining. You can 4 terms are remaining. So that terms are, you can see, twice L1 L4 cos phi minus twice L1 L2 cos theta, and this term you can take common something. You can say minus twice L2 L4 cos theta cos phi minus twice L2 L4 sin theta sin phi. So cos theta, if I take this common, let's say right here now it is, so twice L1 L4 cos of phi minus twice L1 L2 cos theta, and remaining 2 terms. What the terms are? This is minus, taking common, minus twice L2 L4 is common. Remaining term is cos theta cos phi plus sin theta sin phi. So what is next? Yes, now further simplification. So I can write it as L3 square is equal to L1 square plus L2 square plus L4 square. This two term as it is. So plus twice L1 L4 cos phi minus twice L1 L2 cos theta. What about this term? Cos A cos B plus sin A sin B.
cos of theta minus phi.
Very good. So I can simplify it as minus twice L2 L4 in bracket. I can write the simplified term as cos of theta minus phi. Okay. Now cos theta minus phi. Okay. Further, in order to get equation which is desired equation, what we'll do here, we divide this equation, whole equation, by twice L2 L4. So let's take to one side now, or before that we'll take this term to that side and then divide. So what I do here, I take L3 square on this side, so it's L1 square plus L2 square plus L4 square minus L3 square plus these two terms, and this minus term to other side. So I just simplify it as L1 square plus L2 square plus L4 square. I take this L3 square here. So it is minus L3 square plus twice L1 L4 cos of phi minus twice L1 L2 cos theta. And this term to other side. So it is equal to twice L2 L4 in bracket cos of theta minus phi. This is my next simplification. Now divide this equation, whole equation, by twice L2 L4. So dividing by twice L2 L4, and then if I divide it, what we get is it is L1 square plus L2 square plus L4 square minus L3 square divided by twice L2 L4 divided by each term. So divide to this, then divide to this. If I divide to this term by twice L2 L4, what you obtain? So twice 2 to get cancelled, L1 L4, what remaining? Yes, tell me please. Second term means I want to divide to the second term. I take three terms, first term, second term, third term, divide by twice L2 L4. So what you obtain remaining is, yes, it is L1 upon L2 cos phi. As this L4 get cancelled, 2 get cancelled, and this cos phi as it is. Similarly, here it is
L1 upon
it is
L4.
minus L2 get cancelled, 2 get cancelled, L1 and L4. So minus L1 upon L4 cos of theta, and is equal to, as we divide by twice L2 L4 to the same term, this get cancelled, and hence it is equal to cos of theta minus phi. Now we can write this equation as, so above equation can be written as, these constants will write, because you can see L1, L2, L3, L4 in the first, all are constants, all are linked lengths. Hence I'll write them as K1. We can write here as K1. Let's say call this as K1, this term as K1. So my equation is K1 cos phi. This second term I written it as, let's say this one, it has K2, so it is minus K2 cos of theta plus K3. So this one I called as K3. So plus K3 is equal to cos of theta minus phi. And this equation which I obtain is known as freudenteins equation. So K1 cos phi minus K2 cos theta plus K3 is equal to cos theta minus phi is called as the freudenteins equation, where we know that what is K1, K2, K3? Yes, please. Where K1 is equal to, tell me please, what is magnitude of K1, K2? K1
L1 square plus L2 square plus L4 square minus L3 square upon 2 L2 L4.
check it carefully. I just rearrange that term.
L1 upon
It is, yes, K1 is this one, K1 cos phi I said. It is only constant here. So K1 is L1 upon L2. K2 is, yes, now K2 is,
L1 upon L4.
very good. K2 is L1 upon L4, and K3 is the term Aditya said. Okay, that is nothing but L1 square plus L2 square, remember, plus L4 square and minus L3 square upon twice L2 L4. Okay, so now I just derived freudenteins equation, but the question may be in your mind, how it is, for what it is useful, why we derive this equation. Remember, this equation is used for dimensional synthesis. As we seen, our title is analytical method for dimensional synthesis of 4-bar chain mechanism. So this is analytical method, analytical equations we want. We need to derive some equations so that we can derive dimensions of 4-bar chain. Means we need to find out L1, L2. Dimension means we can find out L1, L2, L3, L4. Provided that some input is given to you, maybe theta and phi is known to you. So I derive this equation for dimensional synthesis. I repeat how I derive. Initially, we consider a 4-bar chain mechanism having link lengths L1, L2, L3, L4, and angles, input angle is theta and output angle is phi. We consider vectors equation for displacement of this mechanism. We consider it along x and y axis. So I return these vector equations for displacement along x and y. Then rewriting this equation in terms of L3 to one side, and then by squaring and adding, we get this term. Further, we simplified this equation to obtain this equation in this format. Then by dividing by twice L2, L4, we get this equation in terms of cos theta, cos phi, and some constants. I call the constants as K1, K2, K3. So it is K1 cos phi minus K2 cos theta plus K3 is equal to cos of theta minus phi, where K1, K2, K3 are known to you. Means if for a mechanism, let's say I'm just drawing this mechanism here. This one is fixed link. And we'll talk about like this. Let's say this one is 4-bar mechanism. For this mechanism, 3 positions are known to you for angle. Let's say theta 1, theta 2, theta 3. Means for first position, your input link is having angle theta 1. Output link is having angle phi 1. And like this, I know 2 more positions. Let's say I'm just drawing this one. So this is second position. And let's say this one is third position. So this angle is theta 2. This angle is theta 3. Means I know 3 different angles for input as well as this is output angles. First position, second position, and this one is third position. So theta 1, theta 2, theta 3, and phi 1, phi 2, phi 3 with the input and output angles of the links. If these angles are known to you, and then we need to find out L1, L2, L3, L4. So if this kind of problem is given to you, means for 3 positions of mechanism are known to you in terms of angles. Let's say input angle theta 1, theta 2, theta 3, and output angle phi 1, phi 2, phi 3. How to find out L1, L2, L3? And for finding that, we'll use this equation, freudenteins equation. How we can find out? Anyone can tell me? That means given data is, I'm writing theta 1, theta 2, theta 3, phi 1, phi 2, phi 3. Yes, can anyone tell me how I can find out L1, L2, L3, L4? This is your numerical. Means actually this is nothing but a problem of dimensional synthesis. In the last case I was discussing about talking about problem. Someone said what problem is? Problem is I'm saying statement. So this is my statement. I have to derive dimensions for this. And for this kind of numericals, this kind of problem, this kind of statements, I can use freudenteins equation. Provided that any one link length is known to you. So in given data, I must know any one link length. Let's say L1 also known to you. Or you can assume it. Yes, anyone can tell me how we can solve?
We'll get 3 equations maybe by putting theta
Yes,
1,
that's right.
phi 1.
Yes.
Then solve it.
See, we know only one equation. That is freudenteins equation. K1 cos phi minus K2 cos theta plus K3 is equal to this term. If I use this equation for 3 terms, for 3 positions. So how I can write it as? Yes. For 3 positions. So I can write it as like this. It is K1 cos of phi 1, because of our basic equation is K1 cos phi. For first position, constants will not change. Only angles are changing, and angles are known to us. So it is K1 cos of phi 1 minus, yes, tell me please, minus K2 cos of
Theta.
which theta I have to use?
Theta 1.
theta 1. For first portion, I will write theta 1 plus K3 is equal to cos of S.
Theta 1
Theta
minus
1
phi 1.
minus phi.
Good. It is theta 1 minus phi 1. So this is freudenteins equation for first position. Similarly, I can write for second position, it has K1 cos of S phi
Theta
2,
phi 2.
phi 2, it is phi, so phi 2 minus K2 cos of
Theta 2.
S theta 2 plus K3 is equal to cos of theta 2 minus phi 2, equation number 2. And last one, K1 constant remains same, angles are changing, K1 cos of phi 3 minus K2 cos of theta 3 plus K3 is equal to cos of theta 3 minus phi 3, equation number 3. As I know angle theta 1, theta 2, theta 3, phi 1, phi 2, phi 3, I can solve these three equations. And by solving this, what you can find out is, we can find out L1, L2, L3 and L4. How I can find out this, tell me? Yes, anyone? By solving this, what you obtain?
So we'll get the values of K1, K2 and K3. And then
Yes.
using the relation, we can find out the other values.
That's what. See, by solving this K1, K2, K3, we'll obtain, by solving these three equations, we obtain K1, K2, K3. And once we know K1, K2, K3, and also I'm telling you, one of the link length is known to you, or we assume it, then let's say talk about K1. What is K1 formula? L1 upon L2. L1 is known to me. K1 I just obtained by solving the equations, so I can get L2. Next, L1 upon L4. L1 is known to me. K2 I find out, I'll get value of L4. And similarly, we'll get remaining link lengths. So this is what procedure of dimensional synthesis by using freudenteins equation. What we discussed till now, I discussed derivation for freudenteins equation and its application for a dimensional synthesis. Is it clear?
Sure.
Yes, sir.
Okay. One last topic, one small topic we'll discuss, and then we stop this lecture. Okay. In yesterday's lecture, we talk about Chebyshev spacing method, and I discussed one formula with you. Anyone remember that formula? To find out precision points.
Xj is equals to half of xx plus xf minus delta x upon 2 cos phi 2j minus 1 upon 2n.
Right. So that formula we discussed, and I hope you remember, with the help of that formula, I can find out precision points x1, x2, x3, and so on. Also, I can determine if x is known to me and y is equal to f of x is your function, then I can find out y1, y2, y3. And the next topic is, you can say, angle relationship. So it is angle relationship for function generation. Now see, actually what that x1, x2, x3 and y1, y2, y3 stands for, let's say consider again a 4-bar mechanism. If I consider this link, so I extend it here, you know that this one is theta, or input angle of input link, provided this one is fixed link, and this one is output angle, let's say phi. We need to find out angle relationship for function generation numericals, for function generation problems. And we talk about this displacement of input link as, it may be in terms of theta or it may be in terms of x. So the displacement of this link started from xs, that is starting position, and this one is xf. In between, there are some points, let's say x1, x2, and x3. Similarly, I can get here a displacement for output also. So it started from ys ends at yf, and in between it have some positions like y1, y2 and y3. We talk about this x1, x2, x3, y1, x1, x2, x3 nothing but precision points, and y1, y2, y3 corresponding to output function. Let's say y is equal to f of x. Means in the previous session we discussed about if x1, x2, x3 are known to me, how to find that Chebyshev spacing method we'll use. Once that x1, x2, x3 is known to me, that is here like say x1, x2, x3 up to xn are known to me, I can find y1 to yn. How I can find this? Once these are known, by using this function, I know y is function of x. Some function is given to you. Let's say y is equal to x square. So if x value is known to you, we get value of y. Means with the help of x1, x2, xn, I can find out y1, y2, yn. Now if these are known to me, how I can relate this? Because sometimes it may be in terms of angles, theta and phi. So as there is linear relationship between angular and linear changes, we can write. So can I write like this? Now observe here. I can write range of angles and linear relationship between this theta and x. So by considering this linear relationship between this theta and x, I can write it as theta f minus theta s. What is this theta f minus theta s? Yes. It is a range of theta. It varies from s to f. So we can call it as range of input angle theta f upon theta f minus theta s. It is having linear relationship with this xf minus xs. So it is x of f minus x of s. Range of x, and I can write it as it is equal to delta theta upon delta x. Further I can write like this: theta f is equal to, so this take to one other side, it is equal to delta theta upon delta x into x of f, that is final, minus initial starting point. It is theta f I written here, so it is plus theta s. So it is your equation or angle relationship, provided that displacements are known to xf and xs is known to me. So from this I can write relation between theta and x. So final position of theta is equal to starting position of theta plus ratio of their ranges delta theta by delta x into xf minus xs. So from this, if starting position is known to you, x1, x2, xn, y1, y2, yn are known to me, and theta s is known to me, I can find value of theta. In general, let's say theta s is datum position, is starting position. So if theta s is datum position or is datum, then this theta s is 0. And hence my equation become now theta f is equal to what it will be as? This will become 0 only as it is starting or datum. So I'm writing here it is delta theta by delta x into xf minus xs. But it is for final position. In general, how I can write? For any angle, how I can write this equation? Let's say replace by f by j. J is any position. So theta j is equal to delta theta by delta x into, instead of f, I'll write xj. So it is x of j minus x of s. And so this is your equation for any angular displacement at jth position. I can write. So theta of j is equal to delta theta by delta x, range of theta upon range of x into x at that position minus starting position. Similarly, I can write this where you know that where j varies from, what is j here? The precision points, number of precision points. So j is equal to, it varies from 1 to n actually. J is their position, and it is equal to number of precision points. Similarly, it is I written for input link. What about output? I can write. So for output, I write it as phi. Output angle phi of J is equal to. Now tell me please, anyone. Similarly, you have to write here. Phi of J is equal to last equation we have to discuss, and then we stop. What is phi of J?
Delta
From this
phi,
equation, you can tell me.
delta phi upon delta y.
Yes. So it is phi means output angle is equal to delta phi upon instead of x it will be y into y of jth position minus y of s. So this is your angle relationship for the function generation problem. Function generation means y is equal to f of x. So two formulas will derive. So from this I can find theta 1, theta 2, theta 3 up to theta n. I can find phi 1, phi 2, phi n up to theta n, up to phi n. So likewise, these formulas are important for finding angle relationships. I'll summarize this now. So by considering previous session and today's session, we summarize, we discuss Chebyshev spacing method, then we discuss freudenteins equation and how to find out angle relationships. Let's say, I'll just give you an idea about this, how to use this for solving numericals. So to solve numericals by Chebyshev spacing method, your first step is steps to now see here, either 10 marks numerical can be asked or a 6 marks numerical can be asked. If 6 marks numerical will be asked, they will ask you to find out different angles. Angles at different positions. So what is given to you in the first step, we need to find out x1, x2, x3. So how to find x1, x2, x3, provided that delta, we know that range of x is known to you. So x is varying from, yes, where x is varying? It varies from xs to xf. This one is given to you. At the same time, function y is equal to f of x is known to you. Also in some numericals, then that means xs is known, xf is known, that delta x is known, function is given to you. And we need to find out, let's say, first step, for 6 marks, we need to find out theta 1 to theta 3, phi 1 to phi 3. This is your given data, and we need to find out theta 1, theta 2, theta 3, find out phi 1, phi 2, phi 3. First step, determine x1 to xn. Just tell me how to find x1 to xn. We just discuss this and then we stop. Yes, how to find x1, x2, xn? How to find this?
Using the
So
xj
find
formula.
out, yes, find out x1 to xn by using Chebyshev spacing method equation. That is by using xj is equal to, in the last lecture we discussed this, xj is equal to half of x of s plus x of f minus half of x of f minus x of s into cos of pi into 2j minus 1 upon twice n. Remember, this is by analytical way. We can also solve by graphical. In the last lecture we discussed. So first step, there is option. We can solve by either analytical or by graphical. Analytical means by this formula, and graphical means I just discussed in the last lecture. So determine x1 to xn by either analytical way or by graphical way. In some numericals, they ask you determine by analytical, determine by graphical. So anyhow, we need to find out x1 to xn in the first step. Then in the second step, as we know, y is equal to f of x is known to you. Example, let's say y is equal to x square is given to you. So value of x1, x2, x3 are known to me. I'll get value of y1 to yn. So by using y is equal to f of x, we can determine y1 to yn values. So I can write precision point as, I know x1, x2, xn. So I can write x1, x2 up to xn, and then y1, y2 up to yn. I can write, if I know this, then I can write precision point as x1, y1, x2, y2 up to, we can write up to xn, yn. So third step is writing precision points. And after writing precision points, the procedure we discussed, we can write angle relationships. So find out angle relationships by using relations just we derive. So for this, we'll use equations as theta of j is equal to theta s plus delta theta by delta x into xj minus xs. Also for phi, similarly, for phi of j, we can write it as phi of s plus delta phi upon delta y into yj minus ys. So from this, I get value of theta 1 to theta n, and from this we get value of phi 1 to phi n. This is 6 marks numerical. It's very simple. I repeat, if I need to find out only this up to theta 1 and phi n, first find out x1 to xn by either graphical or analytical method. In second step, use y is equal to f of x to obtain y1, y2, yn. Get precision points in third step, and last step, use angle relationships to get value of theta 1 to theta n, phi 1 to phi n. In addition to this, if they ask you to solve dimensions, to find out dimensions, then use the freudenteins equation, that is k1 cos phi minus k2 cos theta plus k3 is equal to cos of theta minus phi for 3 positions, and get value of k1, k2, k3 to obtain value of L1, L2, L3 and L4. So the last step I just discussed in brief, as we discussed in the at the end of derivation also. Once theta 1 to theta 1, let's say for 3 positions known to us, theta 1, theta 2,
Sir,
theta
last
3.
step is not visible.
Yes, what is not visible?
Last step is not visible.
This fifth one is visible?
No, sir.
No?
Yes, sir, it is visible.
Yes, sir, visible.
Please check. Okay. See, means I know value of theta 1 to theta 3, assuming that 3 points, phi 1, phi 2, phi 3, if their angles are known to you, last step, use this equation just in the discussed manner. Means use this equation for 3 steps, 3 positions, solve them, we get value of k1, k2, k3. And if one of the position is known to you, one of the length is known to you, let's say L1 is known to me, I can find out L2, L3, L4 by using equations we know for this freudenteins equation. This is overall procedure for solving a problem of dimensional synthesis for forward chain mechanism by using freudenteins equation. Is it clear? We'll solve numericals in next. Is it clear? If any doubt, please ask. Hello.
Sir, about
Any
the
doubt
angle,
is there?
sir, about the angle relation. When we found the general equation, we not use theta s. Does that mean generally the value when we use this theta s is always datum?